Hello, today we are going to cover permutations and combinations. Um, this particular topic has been appearing more and more frequently in the 2022 school year, and so we want to go over these concepts. So let's go through the definitions. Permutations. A permutation can simply be defined as the several ways of arranging few or all members within a specific order. It is the process of legibly arranging from chaos. This is what is termed as a permutation. And a combination. These two terms tend to be confused, but I will break this down in a second. Combinations, or the combination, is a process of selecting the objects or items from a set of the collection of objects, such that, unlike permutations, the order of the selection of objects does not matter. It refers to the combination of n things taken from a group of k at a time without repetition. So the easiest way I like to think about permutations versus combinations is that permutations order matters. We have to have specificity. Whereas combinations, we are thinking about groups of things. So as a breakdown here, if we just take the letters A, B, and C, and we want to come up with every single order that we could think of, that is what we would use for a permutation. So permutations order matters. So let's think of all the different ways that we can order A, B, and C. Well, we have A, B, and C. We have A, C, and B. We have B, A, C. We also have B, C, A. And then we can put C first. So C, A, B, and C, B, A. And so there are 6 total permutations here. And we're dealing with 3 particular letters. If, on the flip side, we think of this as a combination, well, combinations, order does not matter. So when I have the letters A, B, and C, and I have to use all of them, this is the only one that matters. Because when we are dealing with a combination, A, B, C is equivalent to B, A, C, which is also equivalent to C, A, B. All these are identical because we're using the same elements. So as you notice really quickly, if we're using combinations, we have significantly less options. We are looking at just groups versus specific order here. So what you will see on the ACT are very straightforward combination and permutation questions. One of the biggest things is to identify whether or not is it a permutation or is it a combination. And so that is the first thing we will do. We need to be able to determine if it is a combination or permutation. And so we're going to look at these few options and then go through the explanations. So 1, a team of 8 basketball players needs to choose a captain and a co-captain. Well, because we're very specifically looking at a captain and a co-captain, this is a permutation. Order matters. We have to choose exactly a captain and exactly a co-captain. 2, Rob and Mary are planning trips to 9 countries this year. There are 13 countries they would like to visit. They are deciding which countries to skip. In this particular case, because we don't know which countries they're going to get rid of and they don't care which ones they go to, we can choose a combination here. Note it's just the entire group as a whole versus actually the specific order at which we are visiting the countries. Number 3, the batting order for 7 players on a 12-person team. Well, the very, very obvious word here is order. Order matters here. The batting order for 7 players on a 12-person team. Yeah, so who is going in what order? This is a permutation because order matters. Number 4, there are 45 applicants for 3 computer programmer positions. Again, it's just for very general group of people. It's for 3 computer programmers. So because the order does not matter here, not comp, but combo or combination. Good. So the next part that you will see on the ACT are the actual formulas to use with permutations and combinations. They can look very intense, especially if you haven't dealt with statistics or probability, but they are very straightforward, and we look at them individually. One, permutations, we usually use the notation of NPR, which is equal to n factorial over n minus r factorial, where n is the total or the total set, and r is how many elements that we want to take from that set. And in general, we will use this formula over and over and over again. I'll give you an example here in a second. A combination is very similar. NCR, in total elements combined r times, or taken r times. And the only difference here between these two formulas is that when we are dealing with combinations, you must take the r factorial and include it in the denominator. So exactly the same as permutations, except we are including an r factorial. Fortunately for us, these formulas we typically never have to work out by hand, but you will be asked or potentially asked to be able to understand or regurgitate these formulas. So you need to be aware of them. In our case, though, we can actually use a calculator to solve pretty much any permutation or combination question if we are to calculate them. And that's pretty easy. Our calculator handles it. And what you can do, here are the steps. You can go to Math. There's a probability button. If you scroll to the right, we want to go down to number 2, which is NPR, or number 3 is NCR. So depending on whether we're working with a permutation or a combination. And just for fun, the factorial button is also within this region. You may need to use it later on. If you hit Math, this is the image that you will see here. And as you can see, we're looking at permutations or combinations or factorials. Note that we're going into probability. Depending on what type of calculator you have, you may have to enter in the first value before you hit or before you go into NPR, NCR. It just depends on what update that you have. Here, and I will show you further. So when I go into my calculator, I go to Math. You can scroll to Probability, and you can go down. My calculator is updated, so if I hit NPR, I have the subscripts, so I can enter them in. So if I have 8 objects taken or permutated 2 at a time, I will have 56 possible values. Again, you don't have to use the formulas by hand. In fact, they actually take a while to do. Rather, we can use our calculators. And since the ACT allows us to use our calculators, I insist that you use your calculator. So further, let's do some more practice. You will have a worksheet attached to this that includes more problems. We're actually doing the first 6 here together, and you will be able to finish it out. The first thing I want you to do is decide, one, is this a permutation or a combination? And then we're going to go through the process. So follow along. So Castell and Joe are planning trips to 3 countries this year. There are 7 countries they would like to visit. One trip will be 1 week long, another 2 days, and the other 2 weeks. So note how they're being more specific here. It's not just general countries and we're getting rid of them as we did previously. In this case, we're doing it very specifically for the first week, the next 2 days, and the other 2 weeks. And so we're going to go through 3 trips. So in this particular case, order matters. So we're going into a permutation. Well, permutations, again, are set up generally as NPR. And so when I want to work with a permutation, I need to figure out what those values are. Well, NPR is equal to n factorial over n minus r factorial. I do recommend writing this out because, again, you will have to regurgitate this formula on the ACT, or it can possibly pop up. In our particular case, how many total elements do we have? Well, we have seven countries permutated at 3 times because we have 1 week, 2 days, and 2 weeks, 3 options. So again, I would just write it out. We have 7 factorial because n is 7 over 7 minus 3 because r is 3 factorial. Now, do not expect you to solve this by hand. We can go to our calculators. So again, I go to math, scroll to probability, and go down to NPR. My calculator has it in front of me, so I can type in 7 and 3 and spit out my answer, which is 210. So this value is 210. The ACT will either have you look at the formula and be able to determine it's a permutation, or it'll actually just ask you for how many permutations it takes. All right, number 6. There are 10 people at a meeting, or 110 people at a meeting. They each shake hands with everyone else. How many handshakes were there? So in this case, it doesn't matter what the order that we're shaking our hands. So in general, this would be a combination. We're just looking at the group of people. So we have a combination. Again, combinations are in CR. The formula is nearly identical to a permutation in factorial over r factorial is the new portion times n minus r factorial. Very similar to a permutation. In our case here, we have a lot of people. We have 110 people, and you can only shake hands with one person at a time. So you and the other person create 2 people. So again, I want you to practice writing this out. You don't have to solve it by hand. We can use our calculators, but practice writing it out. It'll help you memorize the formula. So we have 110 factorial over 2 factorial times 110 minus 2 factorial. Note that we could simplify the 110 minus 2, but we're not going to do that here. Just recognize that. So again, I'm going to go to my calculator. This time I'm working with combinations, so I'm going to scroll to NCR. 110 people taken 2 at a time. So we have 5,995 handshakes. 5,995 total handshakes. Again, we may have to present the combination formula, or we'll actually have to come up with the final number. Last thing is that we have an ACT style question here, and we want to look at this. Let's answer this one. So in a window display at a flower shop, there are 3 spots for 1 plant each. So we have very specific spots. To fill these spots, Emily has 6 plants to select from each of the different type. Selecting from the 6 plants, Emily can make how many possible display arrangements with 1 plant in each spot? Great, so order matters here because we want to make as many different orders as we can. So this is a permutation. And again, since we know it's a permutation, hopefully on the ACT, you just jump straight to your calculator. But I know it's a permutation. It is 6 total plants permutated 3 at a time. So I'm just going to look at 6, not 6P3, but 6. No, it is P3, NPR. So 6P3 equals, and again, I'm just going to go straight to my calculator. I'm going to go to math, scroll over to probability, NPR. We have 6 plants taken 3 at a time, which is 120 order or permutations. So D is our answer. Okay, so from here, you should complete the worksheet attached to this video, and you should be set with combinations and permutations for the ACT. Thank you.